Yeah, so I'm happy to be here from Missoula. So that you don't think I'm just a Western-focused person. I actually did grow up mostly in Virginia. I lived in northern Maine for years as a kid. Worked for the Forest Service earlier in my career in Virginia and North Carolina. So familiar with the forest on this side of the country as well. But today what I want to talk to you about, and I'll try and talk quickly so I leave Danny some time during this session, is some of the spatial tools for wildfire risk assessment that have come about in the last decade or so. A lot of it is science that's been developed through Forest Service research in cooperation with an awful lot of other people. And the Fire Modeling Institute, where I work, we get to work in the applied realm. And so we're trying to take a lot of that science and put it to practice. So it looks like my slides are reformatted a little bit here, so bear with some titles. But just real quickly, we all have these landscapes that are a mix of ownership. So this is a map of ownership in the state of Arizona, but it could just as well be anywhere. We have all these different jurisdictions that are mixed. Back here, you guys have even more challenges of all these small interspersed ownerships and parcels. At least in the West, we do have big chunks of federal land. Cross-boundary management of wildfire is key. We can't just work within our own little silos. And we need to do that in line with the cohesive strategy goals of fire-adapted communities, restoring and maintaining resilient landscapes, and providing for safe and effective wildfire response. So those are the driving goals behind a lot of this risk assessment work. I'm going to just skip ahead. So the role of wildfire risk assessments in achieving those goals, from a pre-fire planning perspective, we can use, when we understand about the hazards and the risks in any given location, it can help with treatment prioritization and strategic fuels management. How do we prioritize our work? How do we allocate our dollars from a national perspective or a regional perspective? It can help us identify the stakeholders. So once you understand the scope of where fires are coming from that impact a particular area of concern, you know who the partners are that you need to be talking to. And it can help to inform community planning efforts, and I'll give some examples in this talk about how it's being used to help develop WUI codes and regulations and community wildfire protection plans. From a wildfire response perspective, from the outputs that we get from these spatial wildfire risk assessments, we can delineate spatial wildfire response zones that help managers understand where community protection versus restoration of fire-adapted ecosystems can be achieved in different places. It can also help provide effective communication on incidents between the incident management teams and the public. So if you can convey what are the things on the landscape that are at risk, what are we trying to protect and why, and how are we going about doing that, you can be very effective at doing that. I'm on an incident management team in the Northern Rockies with a focus on, it's a holdover from the old fire use days. We're a wildlife fire management team, and I think one of the things we do best is convey to the public, this is why we're managing the fire the way we are, because these are the things that are out there that we're trying to protect, or that we're trying to keep the fire away from, or whatever it might be. Overall, risk assessments can help us with integrating wildfire management into general land management objectives. So what is a wildfire risk assessment? And again, sorry about the slide for a minute. The basic definition, so risk is a word that gets used for a lot of things. Firefighter risk can often refer to safety. Here, wildfire risk is a measure of the probability and consequences of some uncertain future wildfire event. So probability and consequences are key to that definition. We like to use this triangle to talk about that a lot, and the three sides of that are the likelihood of fire occurrence, the likely intensity of fire at any given place, and then the susceptibility of values or things of value on the landscape. And this schematic on the right kind of shows when you can pull together spatial information representing all of those things, then we can calculate risk. Some terms that are associated with that are hazard. So hazard generically is a physical situation with the potential for negative consequences. And here, we're getting that from simulation modeling. So we can do modeling that will give us information on the burn probability, what's the likelihood of fire at any location, and on the likely intensity if fire occurs in any location. When we put those two pieces together, we can calculate a measure of hazard. Exposure is another term we talk about a lot, and that's basically just taking that measure of hazard and overlaying it spatially with where those things of value are. And so, you're acquiring GIS layers for things like homes, human communities, municipal watersheds, wildlife habitat, infrastructure, etc. Okay, so real quickly, how do we go about doing these? I just mentioned those three pieces of information that we need to calculate risk. And so I'm going to work backwards here. We get the likelihood and intensity information from fire modeling. Like we've heard today already, all models are wrong, some are useful, so you have to take it with a grain of salt, but it's, and it's built on fire spread equations that go all the way back to 1972, the Rothermel spread equation, but we have pretty sophisticated spatial fire models that work pretty well. We're in the process, actually, at the Fire Lab, of doing a lot of research to revamp those. We're not there yet, but we use the fire modeling tools that we have to develop likelihood and intensity. We need these kinds of data sets to feed into that. So fuels, topography, weather, fire currents, the landscape file that Megan told us about just a little bit ago. Then in terms of the values, that's where we really need information from whoever we're doing an assessment for. So if we're doing an assessment for a local community, we need to sit down with local community stakeholders and find out what's important to you. If we're doing it for a national forest, same thing, the fire management staff. If we're doing it, I'm doing an assessment for all national forest system lands in the United States. I need to be talking to people at the Washington office level, what's important to you. Once you have the appropriate level stakeholder input and the best data possible that's consistent across your work area, then you can do the work to develop a risk assessment. So a little bit about the fire modeling tools that we use. The one that's really the best for sort of broad scale risk assessment applications is called FSIM, or the Large Fire Simulator. It's built on the same concepts as some of the other fire models that have been mentioned this afternoon, like Farsight and FlamMap. But FSIM is this, it's on steroids. It runs in a Monte Carlo mode where you're running tens of thousands of iterations of fire season simulations. In each of those fire seasons, you're placing ignitions on the landscape according to where you've seen ignitions in the past. And you also are generating weather streams based on weather station records from the past couple decades and generating all statistically possible variations of weather across your landscape. And so the figure at the left is showing you're covering the whole statistical variability of weather, all extremes, and you're running thousands of iterations, and that's how we can generate those surfaces of probability. We can also use FlamMap, which just models for one particular weather scenario. And so in that case, we'd be looking at the extreme, the right side of that distribution. What's your 95th percentile weather day, for example, your problem fire scenario. And again, run that thousands of times, saturating the landscape with ignition, so you know what's the probability of fire at any given location under that weather scenario. So just a little side note about some data sets that are available. This work is done, the FSIM work is done at a national scale, and it's done by some colleagues of mine at the Rocky Mountain Research Station. I know those links at the bottom are probably too small to read, but hopefully these slides can be made available to you. And so these data sets of burn probability and conditional flame length are available to download through the Forest Service Research Data Archive. And they actually can be a pretty decent starting point, even for a community level risk assessment, if you don't have the means to do fire modeling yourself. We've been talking about a 30-meter pixel size as a standard. These national data sets actually use 270-meter pixels. So it's coarse data, but honestly, it's actually really quite good. And so these are available, and it's what we use for a lot of the projects we do. So I've got some examples here from a community assessment that I've worked on this year for the community of Bemidji, Minnesota. And in terms of pixel-based outputs, here we actually just took those national data sets that I showed you and did some summary of them. But we have the likelihood and intensity pieces of information. So here's the burn probability for the area around Bemidji. Then we can derive metrics like hazard. I mentioned that's a combination of probability and intensity. We can calculate measures of exposure, housing units exposed to wildfire. And we can develop a community fireshed, and I'll show some pictures of that in the next slide. Then what we've been doing for community level assessments is actually, those pixelized outputs can be a little bit hard to look at, hard to pull patterns out of. And so we've actually been summarizing those to watersheds and using 12th code HUC watersheds for landscape scale summary. And so here you can see this is again that burn probability that we looked at in the first image, but now that it's summarized to watersheds, you can very clearly see what the pattern of burn probability is across that particular landscape. And when we've shown these, even though this is based on national data, when we've shown these to the fire chief and the local land use planners there at Bemidji, they are really happy with it. They say, yeah, it's spot on, that's exactly what we see. This is another community, Chelan County in Washington State, where a colleague of mine has been doing the same kind of community assessment this year. And again, the likelihood and intensity summarized up to those 12th code HUCs for a landscape scale view, and then the product of those represents the hazard. And then we can plot those on a scatter plot like this, where, let's see, which is the, there we go. So the horizontal axis is your burn probability, and the vertical axis is your intensity. And so we can see how each of those factors contributes to the hazard. And these watersheds are numbered. You can find the watershed number and see where it sits. The areas with the highest hazard would be up here in the plot. The areas with the lowest hazard would be down here. So it's just another way to kind of pull those pieces apart to see what's contributing to the hazard in any given watershed. We're also taking then flam map modeling, which is done at a smaller pixel size, the 30-meter pixel size, with fuels, just like Megan talked about, doing critique down to the local scale. We worked very carefully with local fire managers to get the fuel models really dialed in on this flam map model, and then summarize those results to a smaller watershed. These are NHD catchments, very small watershed polygons, and that can be used for, say, neighborhood scale planning. Okay, so moving on to the community fireshed concept. So a fireshed, as we use it, can be thought of in the same context as like a watershed. So a watershed is the area where water may drain to. Here, fire is the area that contributes fire to any given destination point, line, or polygon. So the example on the left is the area around Missoula, Montana. This is one that I just did recently. And the orange represents their WUI, and the purple represents where you have simulated fire ignitions that had final fire footprints that impacted that orange WUI area in some way. So in our FSIM simulations, we get not only the raster outputs, but we get the individual simulated fire ignitions and their associated polygons. So that's the data that we can use to generate these types of fire sheds. The one on the right, or my right, your left, is for Bemidji. And for that one, we actually generated a couple different fire sheds. But here, again, we identified all of the simulated fires that impacted the jurisdictional boundaries, and then used the outer footprint of those simulated fires to delineate the fire shed for that community. So one thing that we've been doing in these community level risk assessments is providing WUI maps, updated WUI mapping for communities. As you probably have here, we certainly have the situation in the West. There's a lot of inconsistency in how people map WUI from one community to another. There's a publication that came out in 2015 that is a national wildland-urban interface map and data set that was based on the rules that are published in the Federal Register but applied spatially. They used census block polygons as their base mapping unit, which is fine, but they can be a little bit coarse and a little bit crude sometimes. And so we've actually, for communities, been taking their local address point data and then creating a structure density map from that, and then using the density thresholds and some vegetation thresholds to develop WUI maps for communities. We've also been developing a mitigation difficulty map, which essentially takes slope, it takes the dominant vegetation cover, tree, shrub, or herbaceous vegetation cover, and it takes crown fire potential and puts those together into just a numeric rating of how difficult is it going to be to mitigate your wildfire hazard there. So when you put that together with the map of hazard, it can be very informative. All right, so just real quickly, I'll go through a couple other related products that we're producing out of the risk assessment. I mentioned wildfire exposure. And so what we have with the map here is, again, Bemidji, Minnesota, and they had 5 fire districts around the community of Bemidji that we wanted to include here. And then in red, you see that fire shed that I delineated. The gray dots in there that are just very dense actually are all the simulated ignition points. So in that community, the ignitions are happening in the community. The fires don't tend to get very big. They don't tend to spread very far. So the Fireshed doesn't stretch very far outside of the community. But we wanted to know what's the exposure to housing units, for example. And so, and what's the transmission of wildfire from one fire district to another. So the figure on the right is showing for these 5 fire districts. In gray, the amount of area burned that stayed within a given fire district. In black, it's fires that started in that fire district or that started in another fire district and burned in. And then white are areas that started in a given fire district and burned out to another district. And then we can look at housing units exposed in the same way. So we can say that clearly Bemidji, which is the central fire district here, has the highest level of housing exposure to wildfire based on our simulations, and that most of that is coming from fires that start within that fire district. Taking that one step further, we also wanted to look at, sometimes this is done with land ownership categories, but here we wanted to look at kind of a mixture of land use and jurisdictional categories. And so the map on the left shows what those categories were in that Bemidji area, and we could ask the question, okay, well, where are we seeing, what land uses are we seeing the most fire in? And so we can, again, identify where there's non-transmitted fire that stays within the given land use in the gray, fire that's moving into a given land use in black, and fire that's moving out of that land use. And you can see that, forest, park, wildlife, agriculture, those are the areas that are experiencing the most fire in this area. But then when we look at housing units exposed, as you would expect, residential actually has the highest number of housing units exposed, and a lot of that is incoming from other land uses. So these types of things can just help stakeholders identify what's happening in their area in terms of hazard and risk and who's sharing fire with who. And then just the last thing I'll show is you take that one step further to do this network analysis. Each circle here represents one of those categories, and the size of the circle represents the amount of fire relative to others. So for example, this is tribal lands. They have much less fire, and it's a much smaller footprint spatially, same with developed and commercial. And the size of the arrows connecting them represents the amount of fire being transmitted across boundaries there. So these you have to kind of stare at for a little while, but they actually can be pretty informative. And there's, of course, a lot of statistics behind that too. Okay, so I sort of flew through that, but it gives you an idea of where we're going with a lot of this spatial wildfire risk assessment work. This is Forest Service research, but like I said, we're collaborating with people in the private sector as well. These are some resources. So the risk assessment data that I showed on a previous slide, again, those links are here. I'm sorry, they're right here. These are just some documents, actually, some publications that are very helpful, foundational information. WUI mapping guidelines from that national publication are available here. And I just was going to mention, I gave examples from communities here. The Rocky Mountain Research Station has partnered in this last year with Headwaters Economics, which is a nonprofit out of Bozeman, Montana. And they run this program called CPAW, or Community Planning Assistance for Wildfire. And the community examples I showed here were part of that program. And in the 2018 set of communities that they're just starting to work on, actually it's the first time they're moving all the way to the East Coast. They will be working with the township of Ocean in New Jersey. So stay tuned. Maybe we'll have more about how that assessment goes next year. And feel free to contact me if you have any questions too.